Hello everyone! Chapter 2, video 5. This is Miss Osier.
And Miss Lahar.
And we're solving exponential equations.
Finally, a
Yay!
real life application, people.
So all of you have been like, why do I have to do this? Blah, 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 blah. Here it is, people. We're finally telling you the answer.
All right, so when you're solving, step 1 is to isolate the term that contains the exponent that has a variable.
If you've noticed, every time we solve an equation of any sort, we're always isolating.
Yes.
Okay, rewrite it in logarithmic form.
Solve it and evaluate
And
using
solve
your
that
graphing
bad boy.
calculator.
Look at us go. All right, here we go. So, the x is in the exponent. This is problematic. So I'm going to first make sure it's isolated. There's nothing else touching this 2.
Yep.
Nothing else. Then I'm going to rewrite it in logarithmic form.
So remember, your base becomes your little number. What it's
Little
equal
baby
to comes with a bigger number, and then the exponent pops out.
Because remember, a log is an exponent.
Yep. And then as of class,
Yep.
yesterday, we know how to plug this into our calculator, and
Boom.
out pops an answer.
Boom.
That's what it'll look like.
Nicely done.
And that's what it pops out. And I'm checking. So always check your work.
Check
and
it.
use second function answer so you can see that it actually does come out to be a nice 1,560.
Look at us go.
All right.
Over here. Now, even though there's a -5 there, that's attached to the exponent. So
Yep.
it is isolated. The base that has the exponent is isolated. Rewrite it.
Okay.
Do your thing.
Evaluate the log.
And then now we still have to keep going.
You still have to solve.
We have to add 5 to both sides, and we have to multiply by 2 on both sides. And look at us go.
There's your answer.
That's 50. Woo!
Pause it if you need to write it down.
All right.
Now we isolate.
Now we're isolating definitely. Because, again, the 2 is what has the exponent. So we're adding 3 to both sides.
Well, eventually. There we go.
We're going to write it down a couple times.
Yep.
Then we're going to divide by 4. And now that the 2 is isolated,
Yep.
we can rewrite it as a logarithmic expression.
Yep. The base becomes a little number, yada, yada, yada. You
Boom.
plug it in. That's what pops out of your calculator.
And that's your
then-
answer.
And that's your answer.
Over here, we're going to isolate the base that has the exponent. We're going to divide by 17 on both sides. And we're raising it to the x to the 3rd. So now we can do the log.
All right.
Boom.
So again, base, what it equals to. I popped it over there.
Okay, and now we have to still multiply by 3 to get x by itself.
So we
So
get
that's
that.
happening there.
You multiply by 3,
Boom.
and there's your answer.
So really, you just have to do this log step in order to get it down to something you're used to. They're going to be ugly numbers.
Yep.
Like it's
You
going
just
to
gotta.
happen.
My suggestion is to leave it in the calculator and like keep going, like
Yes.
to hit times 3, and then it'll keep moving your answer.
Don't round it.
Don't round too early.
That's going to be a pain in the butt for you.
Oh
All
my
right.
God, a word problem.
A biologist, blah, 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 blah. Okay, he's observing bats, and there's 104 bats when he starts. He believes the bat population is growing at a rate of 3% per year. Oh, now I'm thinking last chapter. Write an equation of the number of bats as a function of the number of years since the biologist started observing them. And now we're going to use the equation to algebraically determine the number of years it will take. So that's why this is part of logs. So we're using just the normal
1 plus R.
increasing 1 plus R1. Okay.
P is the starting value, so we had 104 bats to begin with. It's increasing at a rate of 3%, so that's where that came from, and yada, yada, yada.
And now we need the exponent.
We
So
want to
again,
know when it equals 200.
yes, we need to isolate. Okay, so we're setting it equal to 200, and we're dividing by 104.
That's what that fraction is. Simplified. Don't freak out.
And now that we have 1 300ths, we are going to switch it to a log and type it in.
Yep.
And look at us go.
And then round to the nearest year, so that would be 22 years.
And that's your answer. So
And
look at
that's
that,
it.
everybody. That's what we're actually doing with all of these properties. We're using them to solve. Have a wonderful day, and we'll see you in class.